The fifth example, we've got a double angle. So we need to look back at our double angle identities. We know that the cosine of 2 theta can be written in 3 different ways. I'm just going to choose the first one because we've got both sines and cosines in it. So r is equal to 5. The cosine of 2 theta is the same thing as the cosine squared of theta minus sine squared of theta. Now, it'd be really nice to get rid of those cosine squareds and sine squareds by putting in x's and y's. But the thing is, if I do that, I would need to multiply through by r. So, if I multiply through by r, I would have an r squared here, r cosine squared theta, and r sine squared theta. But I would still have a cosine and a sine left over. Once I simplified, I'd have like x cosine theta, y cosine theta. So I have to multiply through by r again. So let's just multiply through by r squared. Because if I have r squared cosine squared theta minus r squared sine squared of theta, I can say x squared minus y squared. So let's do that. We're going to multiply through by an r squared. So r times r squared is r cubed. Here I'll get r squared cosine squared of theta minus r squared sine squared of theta. Some of you are probably wondering, why didn't I multiply the 5 by an r squared? Well, what I could do in this step is I could distribute the 5 in and say 5 cosine squared theta minus 5 sine squared theta. And then you can see if I were to multiply everything by r squared, the r's are only going to stay with the cosines, because then I have to factor out the 5 again. So this 5 is not a separate term, so I'm not going to put another r squared with it. This r squared is technically attached to that 5 when I distribute in or pull something out. So now that I've got this r squared cosine squared of theta, r cubed is equal to 5. We know this is x squared minus y squared. Now I run into another issue though. R cubed over here. How do I get rid of an r cubed? Well, you might think, okay, I know r squared is x squared plus y squared. So couldn't I write that as r squared times r? Well, then you're going to run into the same issue that we talked about on the previous problem where I've got this extra r there, but no cosine or sine to simplify it down. So I need to somehow write this in terms of r squared, but still have it be r cubed. So what is r cubed in terms of squares? And this is going back to college algebra. If I have r squared, I've got to raise it to the 3/2. Because when I raise a power to a power, it's the same thing as multiplying those powers. So if I were to say 2 times 3/2, it simplifies down to 3. So r squared raised to the 3/2 is the same thing as r cubed. So I'm just going to rewrite that left-hand side. And now r squared, I know, is the same thing as x squared plus y squared. So x squared plus y squared raised to the 3/2 is equal to 5 times the quantity x squared minus y squared. So then the last thing we can do is let's set this quantity equal to 0. And if I do that, 0 is equal to 5 x squared minus y squared. And then let's move this quantity to the other side. Minus x squared plus y squared raised to the 3/2.